Hey there, science fans! Today we're diving deep into the incredible world of muscles. Ever wondered how your muscles move you? It all starts with tiny threads called muscle fibers. Imagine these fibers like long, thin ropes bundled together. Each fiber is packed with even smaller protein filaments, actin and myosin. These proteins are the key players in muscle contraction. Get ready to be amazed by the power of these microscopic structures. Think of your muscles like a well-organized team, with each member playing a crucial role. The muscle fibers are the team players, working together to produce movement. Understanding how these fibers work at the cellular level will unlock the secrets of muscle contraction. So let's zoom in even closer and explore the amazing world of actin and myosin. Now let's meet the stars of the show actin and myosin filaments. Picture actin as a long, thin strand like a pearl necklace. Myosin, on the other hand, is thicker with a head-like structure resembling a golf club. These filaments are arranged in a specific pattern within the muscle fiber, giving skeletal muscles their striated appearance. But here's where the real magic happens. Myosin filaments have these amazing heads that are attracted to actin. When a muscle receives a signal to contract, these myosin heads reach out and attach to the actin filaments. Imagine them like tiny hands grabbing onto a rope. This interaction between actin and myosin is what drives muscle contraction. But wait, there's more. The interaction between actin and myosin needs energy to work, just like a car needs fuel. That's where ATP, the energy currency of our cells, comes into play. ATP provides the fuel for the myosin heads to detach from actin and recharge for the next grab. This cycle of attaching, pulling, detaching and recharging is what allows the muscle to shorten and generate force. And what about calcium ions? Well, they act like the signal that sets everything in motion. When a nerve impulse reaches a muscle fiber, it triggers the release of calcium ions. These ions bind to the actin filaments, exposing the binding sites for the myosin heads. Think of calcium ions as the key that unlocks the door for muscle contraction. So how does it all come together? The sliding filament theory explains this beautifully. Imagine the actin and myosin filaments as two overlapping ropes. When a muscle receives a signal to contract, first, calcium ions are released, exposing the binding sites on actin. Then myosin heads, fueled by ATP, attach to actin, forming cross bridges. Next, the myosin heads pull the actin filaments inwards, like pulling a rope hand over hand. ATP allows the myosin heads to detach and recharge for the next pull. This cycle repeats, causing the muscle fibers to shorten and generate force. The more the filaments slide past each other, the greater the muscle contraction. And that, my friends, is how the sliding filament theory explains the amazing phenomenon of muscle movement.